In this video, we're going to talk about piecewise defined functions. A piecewise defined function is a function that can be broken up into several different pieces. And each piece is defined by a different rule or a different equation. So what breaks it up, or how we decide which rule develops which piece, is by breaking it by an interval of the domain. This means for a different group of x values. So we'll say, I'm just going to do a couple of examples with you, and here's the first one. So this piecewise function is divided up into two pieces. For each piece, we have the x value, or the group of x values that we're going to use. So for all the x's that are less than or equal to 2, to calculate the y value, we're going to use this rule or this equation where the y is equal to x squared. So I'll pick an x in this group, I'll plug it in, square it, and that'll give me the y value. Likewise, for the second piece, I'll take x's in this group, all x values greater than 2, and I will use this rule or equation to generate the y value for this piece. All right, so we could break these up into two pieces. I kind of have a t-chart for each piece, and I like to write it with the y because I think that makes more sense to us usually. So I'm going to start actually with the second piece because I want to show you something. So in the second piece, we want to pick x values that are greater than 2. So 2 and up. So for the part that's just greater, not equal to, it's a good idea to go ahead and put in the endpoint of 2. And then we'll talk about how we're going to represent that in the graph. So this is 2 and up, so I could do 2, it's the square root, so 4 would be really nice to look at. You could do 3, 4, 5, 6 if you wanted to, but if you want to try and make some nice numbers, 9 would be a good one because it's a perfect square. Why don't we try and stick with those 3 for the moment? So when I put this in, obviously 2 is not a perfect square, but it is sort of the beginning of this piece of a function. So we take the square root of 2, we can use our calculator for that, and it comes out to about 1.4. I always like to circle this one because this is technically not included in this piece. And so we're going to draw it in as an open circle or a hole. If I plug in 4, the square root of 4 is going to give me 2. The square root of 9 is going to give me 3. Actually, why don't we go ahead and plot those? So we'll come over here to our graph. So at 2, we're at 1.4, but this is the starting point, but I don't actually have a value there, so I'm going to draw it as that open circle. And then at 4, 2, we have a point. And 9, 3, we have a point. This is the square root function, which normally starts at 0, 0 and sort of makes this half parabola shape. So it's still the same shape, it's just that we've sort of cut it off. We're just taking a piece of it, we're not taking the whole thing. All right, so that's part 2. For part 1, we want x values that are 2 and smaller. So again, this one does include the 2, so it would be good to make sure that's on the list. And then numbers that are smaller, so 0, 1, any number would do for this. I'll just go ahead and fill it up. Okay, so 2 squared, that's going to give me 4. 1 squared, it would be 1. 0 squared would be 0. Negative 1 squared would be positive 1, and then positive 4. I'm not going to do the same thing I did over here. I'm not going to circle this one because this x value is included. X is less than or equal to 2. And so I will have a solid point there for this point. All right, so let's go ahead and graph this one. We know it's a parabola. And again, it's not the whole parabola, it's just a piece of the parabola. We're kind of making a cut right here at x equals 2 and gluing these two together. So we have 2, 1, 2, 3, 4, 1, 1, 0, 0, negative 1, 1, and negative 2, 4. It is, and then it continues in that direction because we could keep going with our list over here. But it stops here. So we have a parabola that sort of continues on the left but stops on the right. So this would be our piecewise function. Okay, so I hope that gives you some idea of how these work, right? You can definitely see the two pieces here. And I think you can maybe start to understand the criteria for using the different rules, right? This square root of x versus this x squared. All right, I just have one more for you, and that is kind of a special function. The absolute value function can be thought of as a piecewise function. So we usually talk a lot about the absolute value function and graph it as a whole, but really when we talk about its shape, I guess I'm not really giving anything away. We've graphed this one many times before, so I'll go ahead and say that it is a V, right? So we're going to still see the V, but there's really a rule for both sides of V. There's a rule for the right-hand side and a rule for the left-hand side. So the rule for the right-hand side is if I'm using a positive number, so x value greater than or equal to 0, then the absolute value doesn't really change that. So I get the same number when I take the absolute value for my y value. So the y is equal to x. But if I put in a number that is less than 0 or negative, when I take the absolute value, it changes sign and becomes positive. So when I put in a negative number here for x, the absolute value takes the opposite of that negative and makes it positive. And so this is the rule for that side. Okay, so I want to kind of do the same thing we did last time, just so that I can show you the whole one more time and what happens in this function because it's a little bit different. So let's say I start with part 2. I want to choose x values that are smaller than 0, so negatives. But just like in the first example, I do want to include kind of the end point of this piece. So even though 0 is not technically included, all the numbers leading up to 0 are included. So I want to list that. The opposite of 0 would be 0. Okay, and at least initially we're going to draw this as an open circle. Then for this piece, I want to pick numbers smaller than 0, so something negative like -1, -2. You could list more if you wanted to, but this is probably going to be enough. And then when I plug it into my equation, either here or here, I'm going to take the opposite. So the opposite of -1 would be 1, right? Or negative 1, right, is what I'm doing. Same thing here. This is going to give me 2. So let's draw a picture of that. I'd have an open circle at 0, 0. Then I have a point at -1, 1 and at -2, 2. And so this second part of the function gives me the left-hand side of my V. For the first part, now I'm going to choose x values that are greater than or equal to 0. So just like before, 0 is included this time, so it is not going to be a whole. And I want to pick numbers that are above 0. When I plug them in, the x and the y are equal to each other. So I have 0, 0, 1, 1, 2, 2. Since this is now a point on the graph, it turns out for this function, and sometimes this happens with other relationships as well, that the two pieces actually start and end at the same place, and so they meet. So even though I started out drawing an open circle here, the right hand side is going to fill this in with an actual point. They're kind of overlapping or meeting right there, and so that's what's going to make the V shape that we know about. All right, well, I hope this gave you a little bit of an idea about how to graph a piecewise function and kind of an idea of what it is and what it looks like and kind of the meaning of all the pieces that go together to make the function. Feel free to practice this. I think you have several online that you can use to do that with. So good luck, and we'll see you in the next video.